This is shuyan, and I'm here to give you my presentation. The topic of my project is simulation of a turbo encoder and decoder. My presentation will divide it into 8 parts, and this is the outline. So, if we want to introduce the turbo encoder and decoder, we need to know what is turbo code first. And even if we don't know what is turbo code, but we know this is a word full of information exchange. And in this condition, it's really necessary for us to keep the information in safe places in this noise environment. And turbo code is just for this environment because it's good for error detecting. Turbo codes are a parallel connection of two recursive systematically convoluted codes. The basic differences between these two codes is that the convolutional codes increase the constraint length to improve performance, while turbo codes have a constant length to keep it in a small value. Here is the turbo encoder. So the turbo encoder has two encoders, and they will work together to provide a better condition of correct decoding. And we can see this is the first encoder, this is the second one. So when a data block comes in, it will go to the first one first, and the data block will interleaved and encoded by encoder 2 as well. This is the structure of turbo decoder. It can successfully improve barrier decoding algorithm, so the output range is continuous, so it don't need to be 0 or 1. And actually, map algorithm is a really big part of my progress, but this part is mainly focused on the deduction of the equation, so I don't want to see them here. Instead, I will introduce some information of map algorithm. In today's world, there are only 2 types of soft decision decoding algorithm are widely used. One is SOVA, another one is MAP. SOVA spelled as soft output vertical algorithm. It is really simple in structure, so it has a really low latency. So it will use more in real-time application. But for the map, the maximum in post-truth algorithm, it has much better performance. It can have about 0.5 gigabit better performance than SOVA in lower ISNR and higher bias condition. And this is really good to turbo codes because the first stage of iterative decoding leads to high output barriers, and any enhancement at first stage makes the overall performance better. Here is the modeling and the implementation. This is the final result I get, and this is the improved map algorithm. There are lots of the detail about how I get it, but all the detail are in my report. According to this image, we can clearly see the barriers will decrease with the increase of iteration, and more iteration you do, the faster battery will decrease with the increase of ISNR. I also want to introduce sliding window because it was used to reduce working memory. The essential issue is sliding window technique is that trails terminal in each window is wasted and is usually not finished. The decoding window usually makes up of valid bits, and some access accidentally decode bits of lines like 4 or 5 times the constant lines. Hence, incorrect decoding in the last few bits occur. It means this part. And decoding is doing in next window, so like here. This part are not done in the first window, but this part will still going in the next window. So this will provide us a better performance of decoding. And I have 2 related work about in this project. The first one is turbo codes used in wireless sensor network. First of all, this is really powerful ECC technique, and a low power turbo encoder and error correction sequence are implemented at the sensor nodes, and the self-decision iterative decoder is implemented at the same station. This method enhanced the reliability of the network communication, and it was mostly used to monitor, isolate, and remote area, and gather information about unexpected phenomena like around volcano and or in some enemy movement. The second related work is comparison between turbo equalizer with and without conventional encoder or decoder. So first you need to know Gaussian minimum shift keying modulation is extremely useful, and use small receiver structures for GMS key system will help us to get a better quality. And also there are 2 steps for us to get into a turbo equalization procedure. Here comes to the conclusion. The conclusion for this project is divided into 3 parts. First, the turbo code is really good because it can provide us a more security communication area. It has a pretty low battery in low ISNR condition. Thus, it's really suitable for the wireless application, which has a low transition power desire. But the fading field really needs us to study more. We haven't done a lot of into this part. And in the processing of doing this project, I feel like I have 3 parts can be improved. First is about time schedule. I make a time schedule, but I didn't really follow it, so it made me so hurry to finish it now. And also, I don't have the correct software like the MATLAB I need to use in this project. And also, I find my math is not that good actually, because it's kind of hard for me to do the deduction of all those equations. And these are all the parts I need to improve. Thank you. That's all.